All right, let's are we recording? We are. Okay, let's open up our software tool. Now, what did I do last time? I remember solving 104, so I think we're on 105. A family bakery makes cupcakes and sells them at a local outdoor festival. For a music festival, there is a fixed cost of $125 to set up a cupcake stand. The owner estimates the cost is 75 cents to make each cupcake. The owner is interested in terms of the total cost as a function of the number of the cupcakes. Find a linear function to represent the cost. 125 plus 75 cent a cupcake. Okay, that's that. Find the total cost to bake 160 cupcakes. If the owner sells the cupcakes for 150 a piece, how many cupcakes does she need to sell to start making a profit? So we can make a revenue function, and it's 150 a piece, and we need to solve for when revenue equals cost. Okay. So A we've done. So the answer is the owner says, yeah, they won't start making a profit until they sell more than this number. So she must sell 167 or more cupcakes. Okay, so 105 is correct. Okay, that's good. That's good, right? Now on to 106. House is purchased for 250,000. Is expected to be worth twice its purchase price in 18 years. Find a linear function for the price. So we start off with 250,000, and then it's going to be worth twice its price in 18 years. So 250,000 divided by 18 is how much it's gaining per year. Um, let's run this now. So that's the slope. Can I get the whole line numeric? Yeah, so actually let's put this. I can put this as numeric. Okay. Okay. Right, so there's the function numerically. So we have to interpret the slope of the graph. So each year the house will increase at 13888.89 roughly dollars per year. Or maybe I should say that the house will increase at that much per year. The price of the house, is it? The value. Okay, find the price of the house 15 years from when it was originally purchased. So that's not quite double because it's not 18 years. Let's put this numeric. Oops. Whoops. Mixing up my letters. Mixed up X and T. There we go. 458,333. Okay. Okay. That looks okay. Gotta be careful with my letters. PT, PT, there's PT, there it is there. And then we make it numeric. Yeah, the value of the house. Yeah, yeah. And then after 15 years. Yeah, okay, I think that's okay. Now 107. The car was purchased 26,000. The value of the car depreciates 1,500 per year. Find a linear model for the value of the car. Let's be careful now. BT is 2,600. The value of the car depreciates 1,500 per year. Find a linear function that models the value and then find and interpret feed for. $20,000. So the car's worth 20,000 after 4 years. That's it, isn't it? Okay, that looks okay. 108. A condominium in an upscale part of the city was purchased for 432,000. In 35 years, it is worth 60,500. Find the rate of depreciation. Is that realistic? Okay. But the problem is we don't know what the rate is. Is it linear? Is it exponential? I guess it's linear because all the questions have been linear so far. But it'd be nicer if they said that in the question. So the value after T years is 432,000 minus 60,000. Oh, now that's how much it's worth. So I should find out how much it's lost per year. So 432 minus 60. 432,000 divided by 6. Okay, so that's how much it's losing per year, about 10,000. Okay, so that's all we have to do. Find the rate of depreciation. That's it. $10,614 per year. Okay. 109 now. The total cost C to produce a certain item is modeled by the function cost X is 1050x plus 1050 times x plus 28,500. Determine the cost to produce 175 items. So that's 30,000 approximately. That is 109. Yep. Okay. All right. 110 now. A professor asks her class to report the amount of time T they spend writing two assignments. Most students report that it takes them about 45 minutes to type a 4-page assignment and 1.5 hours to type a 9-page assignment. Find a linear function that models this situation. Okay. So 45 minutes to type a 4-page assignment. So you might be tempted to think per page is 45 times divided by 4. But the problem with that is if you divide 45 minutes by 4 and then multiply it by 9, you don't get an hour and a half. And that's because what's happening is that there's some fixed amount of time a student spends on the assignment before they begin. So it's like some kind of A plus B T. Now, I'm going to leave it like this for the moment. And then I'm going to try and solve when n 45 minutes. So we'll say that's 3/4 of an hour. No, sorry. The T is wrong. It's not, it's the number of pages, so P. So the time for a 4-page assignment, that should equal 45 minutes. And then N for 9. That's 1.5 hours. So that's 1.5. And I want to try and solve for A and B. Okay, so I have the A and the B. So let's redefine the function now, if I can. 3/20 plus, also 3/20, 3 times P over 20. And let's test that it works by looking at the time for 4 and for 9. 3/4 and an hour and a half. Okay, so that formula checks out. No, that's part A done. Find the linear function. Use part A to determine how many pages can be typed in 2 hours. So now I want to solve when will, for NP equals 2. So 12 pages and the 13th page is in progress. Okay. And use part A to determine how long it would take to type a 20-page assignment. Well, let's just end 20. So, yeah, perhaps like 3 and a bit hours or something. Yeah. Yeah. That's what's that? 9 minutes, isn't it? So 3 hours and 9 minutes. Okay. Good. Okay, that's that one done. Let's have a look at 111. Okay. The output as a percentage of total capacity of a nuclear power plant in the United States can be modeled by the function PT. 1.8576 T plus 68.052, where T is time in years and T0 corresponds to the beginning of 2000. Use the model to predict the percentage output in 2015. All right. 95.916%. Hmm. Should I not say use the model to predict the approximate percentage output, since I don't think I typed that in wrong. 1.8576t plus 68.052. Well, use the model to predict the percentage output in 2015. Does that mean the beginning of 2015 or the end of 2015? How much would it be at the end of 2015? It'd be, let's have a look. 97%. Yeah. So if you want to kind of average the two, that would be a valid thing to do, because the question doesn't say. That would be about 96.8. But the answer at the back is 96. So about 96%. I think the word approximate should be in the question. I feel like that's missing. I might add that to the errata list. One of the things I added this week was approved, actually. I got an email about it. It was a question I did a few days ago. Again, with the word approximate was in the question when it shouldn't have been in the question. So I might submit about this one as well. Okay, 112. The admission office at a public university estimates that 65% of students offered admission to the class of 2019 will actually enroll. Find the linear function where n is the number of students that actually enroll and x the number of all students offered admission to the class. Okay, let's process this carefully. The admission office at a public university estimates that 65% of the students offered admission to the class of 2019 will actually enroll. So I guess 65% take up. Find a linear function nx where n is the number of students that actually enroll and x is the number of students offered admission to the class. So that's just actually, it's just going to be 0.65 times x. But it's going to be a little bit weird when it's like decimals. Like you can't have a, yeah. So I won't worry about that yet. If the university wants the 2019 freshman class size to be 1350, how many students should be admitted? Okay, so we want to solve how many students should be admitted. That should say how many students should be offered admission rather than admitted, because admitted makes it sound like they've enrolled. Yeah. Oh, again with the fractions, this is a recurrent theme in this book. Okay, so I'm definitely going to submit about 111 is missing the word approximate. And then that should be offered admission. And then 65% of that number is 1350. So I guess technically it's 20077, but I think it would have been better. Let's see. Just trying to think here. I think 1365 would have been a better number for them to go with. Because if you went with 1365, if they asked for 1365, then the answer would have been 2100. So if they just upped it by an extra 15, you'd get a much nicer answer. Okay, I think I will put in a ticket, so to speak, for those two questions, 111 and 112, because 111, I mean, I'll double check on my calculator. Mm. 95.916, and they have 96. Yeah, I'll put in two tickets so for those two. Okay, and that ends this exercise. That's the second exercise down. 1.2 is complete. Now we'll have to go on to 1.3 tomorrow. Okay, great. That's fantastic. Thanks for watching, and we'll wrap it up there. Hopefully I've not made any silly mistakes today. Please do let me know in the comments if you spot something. Thank you. Thank you.